Hi guys, welcome to our third video in chapter 23. This is going to cover section 23, all about carbonyl compounds, which is a whole group of functional groups that we are going to discuss here. So objectives, we want to be able to draw the structure of carbonyl compounds and the various functional groups that are a part of them, and we want to discuss their properties. And you can see here we have a pretty good chunk of vocab words to go through for this section. So let's jump right in. The carbonyl group is an oxygen atom double bonded to a carbon. That is a carbonyl group. You can see that I have that pictured here. This would be, these are the same thing, just given in two different orientations, vertically or horizontally. You can see these are just a carbon double bonded to this oxygen here. Okay. Now, the first and simplest carbonyl containing group is called an aldehyde. And an aldehyde is any organic compound in which the carbonyl group is located at the end of the carbon chain. And it's bonded to a carbon atom on one side and a hydrogen atom on the other side, where the general formula is RCHO, where R represents any alkyl group, or it could even be a hydrogen atom in this case. Our most simple aldehyde is called formaldehyde. Formally, the IUPAC name for this would be methanal. Methanal with an AL there. You can see that we have our carbon double bonded to an oxygen, so there's our carbonyl group. And because these are both hydrogens, we say this is an aldehyde. It's at the end of a carbon chain, and this chain is one link long, so it's a pretty short chain. To name these things, you change the final E to an AL. Okay, very much identical to how we would name an alcohol in our last video, except that instead of adding OL, now you add AL. Okay, so if we have ethane here, we have our just generic ethane with nothing substituted onto it, and we convert that into this new group where we have a double bonded oxygen to our terminal carbon and a hydrogen on the other side. This group right here tells us that we have an aldehyde because we have this carbon double bonded to an oxygen with a hydrogen on it. And we take our ethane and we replace the last E with Al. This is called ethanal, also known as acetaldehyde, right? Acetaldehyde. You can see aldehyde in the name, acet as in two, right? These are archaic names, but you might see it every so often. The IUPAC name and the official name of this is ethanal, though. Okay, ethanal. Since the aldehydes always occur at the end of the carbon chain, you don't need numbers to list these things unless there are other functional groups present. The common names are usually something that have aldehyde at the end of the word. So like acetaldehyde, acetaldehyde, formaldehyde, right? That aldehyde at the end tells you that it's an aldehyde. Okay. Some examples of these guys in nature would be actually some pretty nice smelling things. So benzaldehyde and salicylaldehyde, I think that's how you say it. Salicylaldehyde. That's how you say it. Salicylaldehyde. And cinnamaldehyde. These two, your benzaldehyde and your salicylaldehyde, those are found in almonds. Actually, that's the flavor that makes up almond is a combination of these two compounds. Whereas cinnamaldehyde, that is what shows up in cinnamon. Okay, and this is an aromatic ring, and you could tell these things that are very scent active, they have aromatic rings. It's not a coincidence. That's why they are called aromatic groups. All right, our next functional group we want to talk about that is a carbonyl containing group is called a ketone. And a ketone is an organic compound with the carbon of the carbonyl group bonded to two other carbon groups. The generic formula is organic group bonded to a carbon with our double bonded to oxygen, bound to a second carbon group. That R prime means a different carbon group. So the generic formula might look something like this after we have some things hooked onto it, okay? So they're named by changing the E at the end of the name to "one," okay, as in ketone. And then you can include the number to indicate the position of the ketone if necessary. So we have this 3-carbon group here. That would be a propane, except we replace the E at the end with "one" because this is a ketone. You can see we have our carbonyl group bonded to a central carbon, so it's a ketone. And because my carbonyl group is on my second carbon, we call it 2-propanone. Common name is acetone. Okay, so you may have seen or heard of acetone before. Okay, that's what that is. It's nail polish remover. Okay, so that's ketones. Pretty quick one there. Let's talk about carboxylic acids, and these ones are this is a group that does in fact contain our carbonyl group, but will also serve as a precursor to other functional groups. So this one's pretty important, I would estimate. So carboxylic acids are defined as an organic compound that has a carboxyl group attached to, so it has a carboxyl group, and a carboxyl group is a carbonyl group attached to a hydroxyl group. Okay, so that's like a weird. Here, let me highlight this in like, oh, it's like same color, right? Let me erase and highlight this hydroxyl group in blue. This is your hydroxyl group here. Okay, so we have our carbonyl group, the carbon double bonded to the oxygen, and then we also have our hydroxyl group here. Now, these two groups have a lot of synergy together. They really change the reactivity of this, and they make it so that this hydrogen at the end is very loosely held because there is a resonance structure where the lone pair on this oxygen could, if I could draw the lone pair here, our lone pair on our oxygen could drop down here, and then this could drop up here. And so we would have even less attraction to our hydrogen here. So it's very easy to remove this hydrogen. Well, removing that hydrogen puts it into solution and is what we describe as an acid, something that donates a hydrogen to solution. So that is why these things are called carboxylic acids. Okay, they are polar and very reactive. All right. Although most carboxylic acids are given common names, the formal name simply changes the ane to enoic acid. Or you could think about it, the E becomes oic acid. So here is an ethanoic acid. You would have your two carbons making ethane. And we can see that we have our carboxyl group here. We have a carbon double bond to an oxygen and bound to a hydroxide. So that ane becomes oic acid. So this becomes ethanoic acid. Okay, so that is how we name these carboxylic acids. There are many carboxylic acids out there, and they're very useful for organic chemistry, but we're not going to talk too much more about them for our high school Regents chemistry. Now, I do want to talk about some compounds that are derived from carboxylic acids because many functional groups actually come from these carboxylic acids. And we can start with this thing called ester, as in, polyester. And that is any organic group that contains a carboxyl group in which the hydrogen on the hydroxyl group has been replaced by an alkyl group. Well, what does that mean? So if I look over here at my what I have my carboxyl group here being replaced by a carbon. And then you can see my ester group is where my carbon double bonded to an oxygen is bonded to another oxygen here, which then continues and is bonded to a second organic group. So this kind of links together my compounds. A very common a very common way we find these things is in fruits, vegetables, sweet smelling things. They are very polar, volatile, and sweet smelling. Okay, so that's how we name these things. Now, to name an ester, you write the name of the alkyl group followed by the name of the acid with the ic acid ending replaced by 8. So we replace it by 8. So this here, this ethanoate, this would be our CH3 bonded to carbon. This would be our ethanoic acid up here. And except it is bonded to a propyl group on the other side of that oxygen. So this becomes propyl ethanoate. The 8 replaces the ic acid. Okay, so the naming of these things, again, it's not the most straightforward thing, but that's esters. They're very nicely smelling, nice smelling materials. I want you to be familiar that these things exist and know basically what their structure is with this central carboxyl group bonded to an oxygen. So this central, carboxyl group there. Okay, we got to talk about one more functional group, another quick one. This is called an amide. And an amide, which is different than amine, but an amide is an organic compound in which the hydroxide in a carboxylic acid is replaced by a nitrogen bonded to other atoms. So here in this case, you can see the blue highlighted nitrogen is replacing our hydroxide group. And that creates what's called our amide group. And to name these things, you write the name of the alkane with the same number of carbon atoms and replace the E with amide. Okay, so we have, in this case, we have two carbons, so ethane, and replace the E with amide. So it becomes ethanamide. All right, ethanamide. All right. And so cool. That is our functional groups that we want to talk about for organic chemistry. A little bit about how each one works, how to name them, and the chemistry of some of them. The chemistry is pretty broad to cover for all of them. Now, before we end the video, I do want to talk about a second type of chemical reaction for this unit called a condensation reaction. And in a condensation reaction, just like the word condensation means where water precipitates out, a condensation reaction, two smaller organic molecules combine to form a more complex molecule, and accompanied by the loss of a small molecule such as water. So in the formation of 3-methylbutyl ethanoate, you can see the combination of ethanoic acid. That oic acid tells me that we have a carboxylic acid. So I have my carbon double bonded to oxygen with an OH attached. Cool. That's going to combine with my 3-methylbutanol. The OL tells me that this is an alcohol. So there's an OH bonded right here. On the third carbon, there should be a methyl. So there it is. There's our third methyl. And so these are going to combine. And you can see in the drawing, it literally takes the OH here and the H here. It combines those two things to form a water molecule that leaves our system. So that's our condensation part. The small molecule is lost. And I have concocted or hooked together these two molecules now. So I have on one side, I have my ethanoate, right? Because now I've lost the ic acid. So this is my ethanoate. This part here makes up the ethanoate. And on the other side, I have my 3-methyl-butyl group. 1, 2, 3, 4 carbons. And on my third carbon, I have this 3-methyl, so 3-methyl-butanoate. So that's how this name happens. But that is a condensation reaction. All right, guys, thank you for listening. That's all I have for this video. I'll see you in the next one.